Hi, Laura. How are you?
Hello, hello. Doing good.
Let's see here. How was your weekend?
Pretty good. I'm actually in like a Airbnb on a farm uh, for the week, working from the country, I guess, hang out on the front patio and like donkeys that you can pet. So I feel like I'm at a petting zoo and it's great.
That sounds like a lot of fun.
Yeah, 11 out of 10 recommend.
We're having construction done, like residing our house. So during the
Mm-hmm.
week, it's pretty much like living in a universe of pounding hammers.
Sounds, yeah. Yeah, we're more like we have the rooster sounds, and that's it. It's more picturesque, but hopefully your new siding is nice and it'll be worth it.
I'm very excited about it, and most importantly, my wife is really excited about it. So it's a great
Good.
distraction.
Yeah, good.
Paul,
Hey,
we are
everybody.
we are following suit and getting siding just like you.
Are you really?
Yeah, after that woodpecker went to town, I don't think we have a choice.
It's awesome
The
when you can
woodpecker
hear
debacle.
a woodpecker just absolutely wailing on your house.
Yeah, just eating all your money.
Yeah.
Great.
Well, we'll start the festivities shortly, but Jeremy, I'm curious to know, you going Masonite or Hardy plank?
We're doing the hardy plank.
Yeah, good choice.
Fancy.
Yep, main selling feature: woodpeckers do not eat it.
Yeah.
Nice.
Hashtag plank chat. All right. Let's go ahead and get started. So today is January 19th, 2021. This is SIG Multicluster. We got a couple things on the agenda today. The first one I put on there from our discussion last time, Chojin and I spent some time looking at caps and trying to see if we felt like work would fit as a KEP, and we thought it really didn't. So one thing that like convinced me that it wasn't a KEP is SIG cluster lifecycle uses a KEP-like process, but isn't writing KEPs. And I guess I had missed when they started doing that, which appears to have been recently. I had remembered that at some point in the past they were writing KEPs for that stuff. So I'm very happy not to make it a KEP. And that raises the question of where do we put it if it's not a KEP? So the Chojin and I had talked about like maybe we can keep it in a Google Doc, or maybe we can introduce a Git repo under the Kubernetes SIGs org that will eventually hold code that can hold the proposals for now. So I wonder if anybody has any opinion about that. I'd probably strongly prefer to keep it in Git rather than having it kind of floating around in a Google Doc, but I'm curious to know what other people think.
I think Git is probably a better choice.
Yeah, I feel like the issue is about discoverability, right?
Yeah.
Yeah. So yeah, I agree that since everything else from a discoverability standpoint, I feel like lives in GitHub when we want people to be able to see it, then it definitely should be something like that.
If that's the case, then I'll write up, and there's no objections, I'll write up a request to have a new repo created. The name in my head was like work API as the name of the repo, since that's what is facing us. And I don't want to go overly generic and wind up with a weird, overly generic thing that has exactly one thing in it. Everybody cool with that name?
Yep, I think so.
Sure.
All right, fantastic.
On a related note, before we change topics, Tim, did we figure out where to put your diagram of the various parts of a workload system?
No, I still have it open here on my desktop. It's in my queue of things to get to when I have time to think about it. So no, we do not have a place for it to go, or I haven't even really decided if, ASCII art or SVG or PNG or something is the right format.
Okay. Because yeah, I still think it would be good to have that somewhere, and maybe alongside the namespace sameness statement or something like that.
It all sounds plausible. I just haven't really put any thought into it.
Cool.
Okay, well, I will make a request for a Git repo later on. And Yuri, you have the next agenda item.
Oh, perfect.
I will make sure that you can share your screen, and if you give me just a moment. There we go. You should be able to share.
Oh. Yeah. Hi, everybody. So I will try to share. Is it visible for you guys?
Yes.
Yes.
Yeah, perfect. Yeah, so I just wanted to make a short demo of a project, open source project that we were busy with in APSA for a while. It is kind of relevant to multi-cluster scenario because it's global balancer. Basically, we tried to build, and we built a cloud-native global server load balancing solution, which is Kubernetes aware. And it's originated in APSA, and APSA is a South African financial organization, pretty huge one. Meanwhile, we have a very strong investment in open source and overall strong open source engineering support. So a task that appeared kind of roughly a year ago was to replace one specific vendor solution for GSLB with open source version, which is cloud native, because apart from it was proprietary, I will not name it for obvious reasons, but it was proprietary, and it actually didn't work for us properly for our Kubernetes clusters. So we built something that is Kubernetes aware, operates with us on top of standard Kubernetes primitives, and obviously extends the Kubernetes API with a CRD. So yeah, it's important to mention that it doesn't have any dedicated control cluster, nothing like that. It's actually scattered over multiple clusters. So yeah, I'll get to CRD in a bit, but here we maybe in concepts there are some picks. So basically, KGB as an operator is deployed on every cluster we want to include into global balancing scenario, and it watch over associated workloads that are enabled for global load balancing. And how to control that stuff is actually very simple, using the special CRD, which is kind GSLB, that exactly this operator watches. So this spec is pretty simple. So basically, it's embedded ingress spec plus the strategy parameters. So in this sample on the front page, we specifying ingress, we specifying backend service to watch, and associated global load balancing strategy. And in case of failover, we also specifying geotag, which is yearly is a part of KGB configuration. So we pinning one of the geographical disparate cluster, we pinning as a main one, right? And another one is acting as a secondary in case of failover. So yeah, that's roughly the concept. And we build it as much environment agnostic as possible, meaning KGB runs as part of itself core DNS process, and it actually responds to a DNS request on its own. It uses external DNS for only single purpose. I will show it in the demo. It only configures zone delegation in a specific DNS providers, and we support several of them. And the rest is self-contained and testable, and we can basically be pretty much assured in our pipelines that operator behaves properly. So only zone delegation to external world, and the rest is self-sufficient. So implementation parts. So we based on operator SDK, operator framework. It's pretty convenient project to create operators nowadays. So obviously Golang one, so because Helm and Ansible part of it are not flexible enough. We operating this kind of relatively complex logic here. Core DNS, as I mentioned, is a part to response to actual DNS requests, and yeah, operator dynamically modifies DNS responses according to load balancing strategy. External DNS to interface with a DNS provider, we kind of internally call it HDNS within the project. So it's Route 53 info blocks and that's one in our case, well, current support. Meanwhile, thanks to this design, well, we've been pretty much agnostic. Even if there is no direct support on some DNS provider, I don't know, let's say it's GoDaddy or whatever, it is enough for operator, I mean human operator in that case, to manually configure zone delegation for GSLB enabled hosts, and it will work. So yeah, so this integration basically makes the zone delegation fully automated. So yeah, etcd operator, it's kind of part that we running core DNS with etcd backend, and we running small dedicated etcd cluster within the KGB namespace to populate these DNS entries, DNS records dynamically. And yes, I already showed only single CRD. We integrated to 3 DNS providers. I already mentioned them. Infoblox was the first one because obviously we first solved our business challenges, and we partially operate on-prem, so Infoblox is our DNS solution internal. Then we started to integrate with more cloud and more popular solutions like AWS Route 53, and recently we collaborated with NS1 guys and enabled integration with them. So yeah, and Admiralty is a multi-cluster scheduling solution. We had a very nice collaboration, and we basically enabled a composition of scheduling by Admiralty and load balancing by KGB. So it worked pretty nicely. So I think I will shortly show a very quick demo. So I prepared the setup for the sake of time. Yeah, so we are creating two clusters, two EKS clusters. One is in Europe, and here we have some shortcuts. One is in US. Yeah, okay. And in both of these clusters, KGB is already deployed. So as you can see, the KGB own namespace where everything related to a KGB operator operations running. So KGB, like a controller itself, core DNS process, external DNS, which is populating the etcd backend, and external DNS dedicated to Route 53 to dynamically configure zone delegation. So KGB also uses additional resource behind the scenes, apart from the standard ones, standard primitives its DNS endpoint from external DNS project, and external DNS is configured with source CRD, so it doesn't watch ingress and service like a very standard scenario for external DNS. Instead, it watches this kind of resources, and I'll show you contents right now. So it's kind DNS endpoint, right? So external DNS watches for this object to appear and converges the state of a DNS provider it's talking to. So in this specific scenario, we configuring zone delegation dynamically. So basically, it's test KGB IO for zone that we delegate to KGB enabled clusters. It's an NS record, and yeah, we had to actually contribute NS record support to external DNS to enable that, and standard glue A records, which are actually populating as NS entries. So European one does exactly the same, but populates its own glue record. So, and just to quickly show it in a route session interface, so you see NS record, which is pointing to NS servers, which are effectively core DNS pods that are controlled by KGB, which are running within our cluster. So that's roughly a setup. And here in test.jslb namespace, we have a sample workload. So it's a standard podinfo, pretty popular testing application, just running there with associated services. Associated service. Yeah. And yeah, how we actually enable JSLB for that. So just quickly. Yeah. So failover custom resource example. So kind JSLB, obviously namespace again. That's exactly from the front page, right? So I already applied it, and it already exists in test.jslb namespace. So that should be a couple of them. One for round robin strategy and one for failover. So if we look at the failover one, yeah, and feel free to interrupt me if you have questions right in line. So we have this JSLB resource. It watches the state of the pods through kind of transitive path. So we have associated ingress, which has a link to a service and eventually endpoints, and down to basically pods liveness and readiness props. So the idea behind this, so it's not a standard load balancer with HTTP end-to-end health checks. It doesn't work really well from our experience in a cloud native environment. Instead, we're actually making very cluster aware load balancer and operator, and we're giving control to the teams through the CRD and the ability to create additional specific props for their applications, and basically control the load balancer behavior this way. So here we see that it's populated by an IP address from EU, and we can quickly check that in the HTTP response of this sample app. I put a message which is depicting the geographical location, so just for convenience. And in the right pane, we basically continue and query that just for demonstration purposes. So that currently it responses with a failover strategy with the main pin cluster from Europe. So yeah, it's important to check where are we in Europe, and we have this failover resource, right? So just for clarity, currently we are in US cluster, and exactly the same resource is applied there. So exactly the same spec without any modifications. But in status, it's visible. It's another cluster, different geotag. Primary geotag, it's still Europe, so it's aware, and it also returns from its own DNS, core DNS process, the responses for Europe. So like they actually copyrighting the state and the information between each other also through DNS protocol. So for the sake of simplicity, this information is not sensitive, and we get rid of a whole class of problem of all cross authentication and all that stuff. So in DNS is more lightweight and it's for that specific purpose than HTTP form of data sharing. So we can switch back to Europe and basically try to emulate the failure standard way by scaling to 0, right? So let's get deploy. Let's scale the deploy under in context to 0. Yeah, and we can observe the status of GSLB. Yeah, so it's already became unhealthy. It's already returning the IP address for America. And there, in case of failover, there is a like kind of small downtime in that scenario, given the limitation of DNS protocol, and also I have some additional caching. It might take a little bit longer, but basically here we are keeping 30-second TTL, right? So there is unfortunately some time to update, but in case of global scenario, at least for us, it's not super critical for like kind of this. This a little bit slow failover, but it should recover pretty soon. So if we switch to US again, check the status. No, interesting. So it's still kind of converging because yeah, now because again they kind of talking to each other, and at that moment is the first time apparently Europe was still returning one kind of healthy IP address. Now it's purely it's converged, and America also returns its own IP addresses from a front-ending load balancer, NLB, like a network load balancer, those ones like standard one, yeah, now they are returning a uniform response. So DK already working, so my curl, like it goes through the scaler and there's some amount of caching, and eventually it should return the US geotag. So while it tries to get there, yeah, not sorry, I was just, you know, it was scroll and it was, it's already returning properly, so it's already fixed itself, you know, roughly within 1 minute. So, are there any questions at this stage?
It's not a question, but I wanted to just like point out that I think the original feature for DNS endpoint in external DNS was added during some of the Federation v2 work. Oh. So it's really cool to see that you're using that.
Oh, that's amazing.
Because we didn't really wind up using it. We got it in, and so I'm really glad that somebody's been able to use it.
Oh, thanks a lot for that, because like initially when I was like kind of composing it up, and CRD source was totally like not on documentation. It was somewhere in a like double hierarchy directory, a small doc, and I was really happy to find it in an external DNS CLI help. So because of it solved a lot of problems for me. So yeah, kudos for that.
Do you think the doc needs to be improved?
In external DNS, most probably yes.
Okay.
Yeah.
So the use case for this is you want to run a global load balancer for a single app, right?
Well,
A single service.
there can be multiple apps, right, on the same cluster, and each of them backed by specific CRD.
So I guess what I meant was each CRD represents a service, right?
Yeah,
It's
exactly.
one-to-one.
Yeah.
Okay.
Yeah. Well, if we actually look at round robin example, so there are, yeah, that's the one. So actually here we have a multi-service ingress spec, and this is for kind of demonstration purposes. So it's round robin, and basically it references multiple apps, right? So one is healthy round robin, another existing but unhealthy, and another non-existing. So here it just to add to this point, it's a rare case relatively, at least for us, how we already, by the way, we already running KGB in production like for half a year. Yeah, so for us, it's pretty rare that we are mixing it up, but usually it's like kind of one-to-one, but there is a possibility to at least like front-end several services with a single GSLB spec. Yeah.
That's pretty cool.
That is cool. I'm curious, have you been following the gateway API coming out of SIG Network at all? Because it looks like there's a lot of overlap in CRD in particular, and it might be interesting to kind of sync up there and see how this fits.
Oh, that's interesting. I was like reading on very high level, so I really would like to dive in. Thanks a lot for suggestion. So is gateway, it's not Ingress v2, it's something different, right?
Ingress v2, yeah.
That's the one, okay.
Ingress v2 is the lazy name for it, but it's much bigger than that.
And the project is service APIs.
Cool. Yeah, just to show this round robin, which is multi-service, right? So yeah, one is healthy, one is populated. For some reason, it's actually should mix. Yeah, one of the clusters is dead. It's okay. One of the application in the cluster is dead. So now it's returns only American ones, and yeah, the other another one is unhealthy, which is totally unhealthy. Okay, yeah. Usually I demonstrated this with an upscale down, but yeah, you got the point. It's really clear and non-existing, right? So yeah, yeah, we see the statuses associated. So unhealthy is unhealthy, not found, suitable, not found, and healthy is healthy. So if we go back to Europe, which is currently scaled to 0, right? And double check that that just will be there, and triple check that it's really Europe. Yeah, and we can pretty much scale it back and see how it will amend a state after a while. So two things should happen. Failover should switch back to Europe, and round robin should return a mixed response. So basically 6 addresses. So 3 from Europe, 3 from US, and mix in round robin fashion. Well, let's first check the state of this guy. Yeah, it looks like it returned to European one. And for round robin, it kind of takes a little while. Yeah, as you can see from response, a real response got back to Europe. Yeah, and we have round robin, this mixed response that I mentioned before. Yes, TTL. So we should wait a little bit, or another 25 seconds, I guess, and hope, and it should return a proper round robin response. Okay. One, and here we go. Yeah. So now it's kind of flipping from cluster to cluster in round robin fashion. Yeah, and that's pretty much two strategies that we support, because we try to keep things pretty simple. So from application team's perspective, these two strategies are currently enough for us, but we definitely want to gather more cases from community, and we have something in our roadmap, but I believe until we have a real consumer, it's not so interesting to implement. So yeah, so these kind of two simple but pretty much reliable strategies that works for us nicely. So that's it.
This is really cool. Thank you.
Yeah.
Thanks a lot.
Yeah, this is a great demo. I really do think it would be worth showing this to the gateway folks too, because I think, like, ideally it would be possible to express your CRD via a gateway class and kind of fitting in that model. It would be a good chance to kind of exercise if that model is flexible enough, and maybe to add whatever you would need so that could be so that the KGB could be supported.
Very interesting. And where are the gateway folks? SIG network?
Yeah.
Yeah, cool.
Yeah, and there's a separate weekly meeting, I think, on Thursdays.
Perfect. Thanks a lot for the suggestion. Definitely will look into it. Thanks a lot for feedback. Really appreciate it.
Have you had a lot of outside contribution on this yet?
Not really. It's mostly AppSec.
Okay.
Yeah.
You're running it in production though.
Yeah, we do. And we actually, we collaborated with several external folks. So Rancher guys, we had a meeting, we got a very nice feedback from them. And I think they wanted to package it in Helm chart, but in their Rancher catalog Helm chart, but I'm not sure if it was done or not. And NS1 guys and Admiralty folks as well. So like this, so that's why this integration. And again, this multi-cluster scheduling with a standard cluster, with virtual kubelet, works pretty nicely with KGB. So in a standard scenario, KGB creates ingresses for you out of its own spec, right? But if you're already running some workloads and you already have ingresses, which is pretty common case, in case of AppSec, we kind of keeping GSLB ingresses and the local ingresses kind of in parallel, just for safety. But some folks, and it was, I think it was directly Admiralty requirement, they want to reuse the existing ingress, right? So I can show it actually in Dog, because it's super simple. So if you want to reuse existing ingress, so there is a possibility to just set a special KGB annotation, and KGB controller will pick it up and create GSLB resource. So it's kind of a bit inversed, and then it will close the loop and it will operate in a standard way. So it was pretty helpful as well for actually a couple of teams in AppSec to adopt KGB. So that's additional way to enable it.
Awesome. Looks really cool. I have some questions about this that like I'll probably ping you about offline.
Oh, that'd be great.
All right.
All right. Thanks, Atom.
Great demo.
Yeah, thank you.
Thank you so much.
So anything, I think that's it for the agenda. Is there anything else folks want to discuss while we're still here, or do you want 10 minutes back? Alrighty, then you are released. Everybody have a great day. We'll see you next week.
You too.
Thank you.
Thank
All
you.
right,
Thanks
take
for the
care, everybody.
demo.
Bye bye.
Yeah, great
Thank you.
demo. See ya.
Thanks a lot. Bye.